Agriculture is the backbone of Bangladesh's economy, contributing to livelihoods for millions. But the widespread use of chemical pesticides is taking a heavy toll on our environment and the health of our people. It is time for a change. A more sustainable approach called Integrated Pest Management (IPM) is gaining momentum around the world. IPM is an effective and environmentally sensitive approach to pest management that utilizes a combination of practices relying less on chemical pesticides. This shift towards sustainable agriculture is not just an environmental imperative. It is essential for the future of Bangladesh's farming communities and health of our nation.
Since biological control is an integral part of IPM, the activity supported Patuakhali Science and Technology and Khulna University to rear parasitoids and release at farmers field in collaboration with the Department of Agricultural Extension.
With support from the project, Patuakhali Science and Technology University and Khulna University established biocontrol laboratories to rear two species of beneficial insects called parasitoids, Brachynabetor and Trichogramma chelonis. A parasitoid is an insect whose larvae live in or on the host and eventually kill the host. Now let us have a close look at the rearing of these two parasitoids. Firstly, we will see the mass rearing of Brachynabetor. The initial step involves developing a parent stock of wax moths. For the purpose, natural bee wax should be sterilized at 125 degrees centigrade and 15 psi pressure. Then, small ball must be made with the sterilized bee wax. When the bee wax gets cool, and put the balls inside a glass jar. Afterwards, release male and female wax moths inside the glass jar for mating and laying egg on sterilized bee wax ball. After 6 to 7 days, wax moth larvae will be emerged. Now it's time to prepare an artificial diet for wax moth larvae. Initially, 1 liter of milk, 250 grams of animal fat, 800 grams of sugar and 300 grams of wax are boiled together to make a syrup. It is mixed with 2 kg of wheat flour, 2 kg of corn flour and 1.5 teaspoon of yeast. Then, the whole mixture is autoclaved at 125 degrees centigrade temperature and 15 psi pressure to sterilize. Once the artificial diet is ready, second instar larvae are transferred to the artificial diet in a bowl. After 18 to 20 days, when the wax moth larvae attain fifth instar in the artificial diet, they are collected in a plastic bottle with a corrugated paper sheet for Brachynabetor rearing. The larvae reach the final instar stage in 18 to 20 days. About 200 larvae are placed in a 3 to 4 liter volume plastic bottle with a corrugated paper sheet. Larvae settle in the grooves of the corrugated paper sheet for pupation, with 10% honey solution placed in paper strips for their food. About 60 female and 40 male adults of Brachynabetor are released in the plastic bottle. The open end of the jar is closed with black cloth and secured with a rubber band. The whole bottle is covered with a black cloth to provide darkness for increased parasitization. The parasitoids lay 8 to 12 eggs on the ventral surface of the host larva after paralyzing it by stinging. Parasitoid grubs feed on the wax moth caterpillar's larva by remaining outside. The whole setup is kept in a rack for 8 to 10 days for emergence of adult Brachyinhibitor. Now we will see the mass rearing of Trichogramma chelonis. 1 kilogram of wheat flour, 1 kilogram of corn flour, and 500 gram of chickpea flour. The whole mixture is autoclaved at 125 degrees centigrade temperature and 15 psi pressure. Eggs of rice meal moth, Corsira cephalonica, are spread over the artificial diet in a bowl. Eggs of rice meal moth, Corsira cephalonica, are used as a host for mass rearing of the parasitoid Trichogramma chelonis. The first step for mass rearing Trichogramma chelonis is to prepare the trichocards. To do so, a coat of 10% gum arabic is applied on the cards and the eggs of Corsira are sprinkled uniformly in a single layer with the aid of a strainer. Excess eggs are removed by gently passing a brush over the card after sufficient air drying under a fan. Label information on the species of the parasitoid and the date of periodization are noted on the cards. The tricho cards with Corsira eggs are placed in a test tube, glass cylinder of suitable size, and the nucleus card with Trichogramma chelonis adults about to emerge is introduced in it. The emerged trichogramma will parasitize the fresh eggs of Corsira placed in the trichocards. Trichogramma adults emerge from the cards in 7 to 8 days after parasitization. To delay the emergence of trichogramma, these parasitized cards can be stored in the refrigerator at 5 to 10 degrees Celsius for 10 to 15 days. When the cards are removed and placed at room temperature, the parasitoids will emerge normally. The emerging parasitoids readily parasitize the fresh eggs. Now these beneficial insects are ready to be released in the crop fields so that they can control harmful insects by parasitizing their eggs and larvae and help reduce dependence of farmers on chemical pesticides. Patuakhali Science and Technology University adopted 2 strategies, including creating demand for biocontrol agents by releasing parasitoids in crop fields in collaboration with the Department of Agricultural Extension and commercializing parasitoids by selling them to corporate buyers.
এই দক্ষিণাঞ্চলের পান্তজন এগ্রো নামে একটি গ্রুপ আছে, তারা আমাদের এখান থেকে উপকারী পোকা নিয়ে মুগ বিনের ফসলে তারা প্রয়োগ করেছে এবং সেখানে ভালো ফলাফল এসেছে। এই গবেষণাগার বিগত 1.5 বছর যাবত এই উপকারী পোকামাকড় উৎপাদন করে যাচ্ছে। এই উপকারী পোকামাকড় উৎপাদনের ফলে শিক্ষার গুণগত মান যেমন বৃদ্ধি পেয়েছে, তেমনি অত্র বিভাগে গবেষণার নতুন দ্বার উন্মোচিত হয়েছে। পাশাপাশি এই উপকারী পোকামাকড় ব্যবহারের ফলে যেহেতু কীটনাশকের ব্যবহার কমে গেছে, তাই আমাদের এই পরিবেশ মানুষ সহ অন্যান্য জীবজন্তু ও পশু পাখির উপরে ক্ষতিকর কীটনাশকের প্রভাব থেকে মুক্ত থাকতে পারবে এবং নিরাপদ ফসল উৎপাদনে এই জৈবিক দমন সহায়তা করবে।
একটি বিষয় যে মাঠে যে প্রযুক্তিটি ব্যবহার হচ্ছে, কৃষকদেরকে আরো বেশি আগ্রহী করে তোলার জন্য, তাদেরকে সচেতনতা বৃদ্ধি করার জন্য ট্রেনিং দেওয়া দরকার। এই জন্য ট্রেনিং প্রোগ্রাম হাতে নেওয়া দরকার। আমাদের বিশ্ববিদ্যালয়ের পক্ষ থেকে কিংবা USAID যদি সহায়তা করেন, তাহলে আমরা ট্রেনিং প্রোগ্রাম হাতে নিব এবং এই ট্রেনিং প্রোগ্রামের মাধ্যমে এই টেকনোলজিটা আরো বেশি যাতে ছড়িয়ে দেওয়া যায় মাঠে আমরা চেষ্টা করব। এখানে কিছু ডেমনস্ট্রেশন প্লট করার প্রয়োজন পড়বে, যাতে করে কৃষকরা বুঝতে পারে যে বায়োলজিক্যাল কন্ট্রোলের কি সুবিধা এবং কীটনাশক ব্যবহারের কি অসুবিধা। এই বিষয়গুলি সরাসরি দেখার জন্য কিছু ডেমনস্ট্রেশন প্লট করলে ভালো হবে এবং ভবিষ্যতে আমরা সেটা করার চেষ্টা করব। আর এই ল্যাবটিকে সাস্টেনেবল করার জন্য আমার বিশ্ববিদ্যালয়ের পক্ষ থেকে আমি আর্থিক সহায়তা সহ অন্যান্য যে সহায়তা করা দরকার সেটা আমি করব।
In addition, with the support from IPM activity, Potuakhali Science and Technology University started rearing and releasing Parthenium beetle to suppress Parthenium weed, which is the first attempt in Bangladesh to control a weed-introducing biocontrol agent.
Around 2022, we tried to find the beetle in Bangladesh. We searched all over southern Bangladesh, we didn't find it. Finally, we went to Rajshahi area and found this beetle that has moved from India to Bangladesh. Then we collected that beetle at Rajshahi, brought to Patuakhali University with Dr. Moshin to multiply and release it at the Patuakhali area, and eventually to release the beetle all over Bangladesh to suppress this weed.
Promoting safe food production and accelerating agricultural export are the two major thrusts of the government of Bangladesh. IPM is an approach which can help in achieving these goals. Mass rearing and releasing of parasitoids would not only contribute to combat destructive insects, but also balance the ecosystem.